Okay, so welcome to Unit 8. We are officially done with the geometry portion of geometry. We covered all the 2D shapes, all the 3D shapes, all that fun stuff. And now we get to finish off the year with my personal favorite branch of math, probability. Probability is referring to how likely something is to happen. So, for instance, you might see something like the probability of making the soccer ball into the goal is 1 out of 5. Which means if this person were to shoot 5 times on the goal, they would make it about one of those times, on average. Now, in probability, there are 2 types of events. There are independent events, which are events that have no impact on each other. Think of a dice. Whenever you roll a 6-sided dice, if you were to roll it once, that wouldn't affect the outcome of you rolling it again. You're not changing the dice in any meaningful way. You're just rolling it multiple times. And each time you roll it has the same odds of landing on any given number. Dependent events are when 2 events rely on each other, and one event changes the outcome of another event. In this case, think of like a deck of cards. If I have a deck of cards and I take out a 9 of spades, I take that out and then I try and take another card. The odds of me getting another 9 of spades are 0 because I already took the 9 of spades out. I had already fundamentally altered the deck in some way. So this would be an example of 2 dependent events, where the second event changes the outcome based on what happened in the first event. And we're going to be able to see stuff like that throughout probability. Now, a lot of times people can overcomplicate probability, but in reality, it comes down to this. You want to put your successes on the top of your fraction, and the total number of outcomes on the bottom of your fraction. And this will give you the probability of whatever event you want occurring. For example, number 1, what's the probability of flipping a coin and landing on heads? Well, a coin has 2 possibilities. I'll flip it and it will either land on heads or tails. So there are 2 possible outcomes. The success criteria here is landing on heads specifically. And coins only have one side that's labeled heads. So the probability of flipping a coin and getting heads is 1/2, or 50%. Example 2, what's the probability of rolling an even number on a die? Now we're assuming a regular die with 6 sides. In that case, I've got the numbers 1, 2, 3, 4, 5, and 6. Even numbers being 2, 4, and 6. These are considered my success criteria. So I've got 3 possible things that lead to a success. So 3 is going to go on the top. I've got 6 possible outcomes because I could roll a 1, 2, 3, 4, 5, or 6. That's all 6 options. Now all I got to do is simplify by dividing top and bottom by 3, and I get the odds of rolling an even number on a single die is 1/2. Example 3. What's the probability of flipping a coin twice and both times landing on heads? Now, we're doing more than just one event at this point. So, whenever we're doing multiple things, we have to have multiple fractions. Each event is its own fraction. So what I need to do is I need to find out the probability of flipping a coin and it landing on heads, and multiply it by the probability of it landing on heads a second time. We already found out the probability of it landing on heads is 1/2. So I'm going to multiply 1/2 by 1/2. Whenever I multiply fractions, I go top to top, bottom to bottom. 1 times 1 is 1, 2 times 2 is 4. So, the odds of me flipping a coin twice and it landing on heads both times is 1 out of 4. Now, number 4 is the most tricky, but it's also why I like probability the most, because it requires you to think in a puzzly manner. Number 4 says, what's the probability of rolling doubles on 2 6-sided dice numbered 1 to 6? Now, whenever we're considering this problem in reality, we want to think about this. I'm rolling a dice twice. The first roll, I could roll it and it could be anything. I don't care what it is. Let's say I get a 3 on the first roll. Well, since I don't care what the first roll is, I've got 6 possible successes out of 6 possible outcomes. It could be any number, 1 through 6. If I ended up rolling a 3, well then, if I want doubles, my second roll has to also be a 3. So this is where my second probability changes. The odds of rolling a 3 is 1 out of 6. Multiply the two events, I get 6 out of 36, which whenever I simplify, I get 1/6. So, the odds of rolling doubles on a dice are 1/6. If that was confusing to you, that's okay. This is just about the hardest type of question we'd give you. Example 5 is more akin to a type of question I'd give you. What's the probability of pulling a yellow marble from a bag with 3 yellow, 2 red, 2 green, and 1 blue? Now, you might remember seeing these types of questions on things like the map test or checkpoints you might have taken throughout schooling, right? So this is the type of problem you're going to see a lot more. Okay? What I want to do is I want to find the total number of marbles in my bag. So I'm going to do 3 plus 2 is 5, plus 2 is 7, plus 1 is 8. I've got 8 total marbles in this bag. So my total is 8. My success criteria is getting a yellow marble. So how many yellow marbles are there? 3. So the odds of getting a yellow marble out of this bag is 3/8. Let's move on to example number 6. Number 6. A box contains 2 red marbles, 3 white marbles, 4 green marbles, and 1 blue marble. Let's take a pause and find the total number of marbles first. 2 plus 3 is 5, plus 4 is 9, plus 1 is 10. So I've got 10 total marbles in this bag. 2 marbles are drawn at random without replacement. That's important. What that means is, whenever I take a marble out of this bag, I'm not putting it back into the bag. I'm throwing it out the window. It's not coming back. So my total number of marbles is going to decrease with my second event. Find the probability of selecting a white marble on the first draw and a red marble on the second draw. So I need to find the probability of a white marble and multiply it by the probability of a red marble. Okay, well, white is my first marble I'm drawing, so the total is going to be 10. And I've got 3 white marbles. So the probability of getting a white marble is 3 out of 10. So now let's say I reach into my bag and I grab a white marble and I throw it out the window. Now I have 1 less total marble. So now I've got 9 marbles. And I want to find the probability of getting a red marble. Well, I still have 2 red marbles sitting in the bag. So the success criteria, I've got 2 options to succeed. Multiply these 2 things together, I get 6 out of 90, which simplifies to 1 out of 15. B is asking us what the odds are of selecting a red marble on both draws. So I need to do the probability of getting a red on the first draw, and then the probability of getting a red on the second draw. Okay, well, let's reset back to the total 10. I've got 10 total marbles in my bag, and 2 of them are red. Whenever I pull into my bag, I pull out a red marble, and I throw it at a cat. Now, I have 1 less red marble. So, I've got 9 total marbles in my bag, and I'm taking 1 of these red marbles. So I only have 1 red marble now, because the other one is gone. Multiply our 2 fractions together, and 2 out of 90 simplifies to 1 out of 45. Example number 7 is talking about a deck of cards. Now, something I thought was common knowledge, but turns out isn't, is that cards, decks of cards, have 4 of every type of card. So it has 4 kings, 4 queens, 4 jacks, 4 tens, so on and so forth. So, there are 4 kings in the deck. 2 cards are pulled randomly without replacement. What's the probability of getting 2 kings? So I want the probability of my first draw being a king. I'm going to multiply by the probability of my second card also being a king, with the total number of cards being 52. So the odds of my first card being a king, I've got 52 total cards. How many of them are kings? Well, 4 of them are kings. So the odds of my first card being a king is 4 out of 52. Then I take that king and I throw it in the fire. Now I have 1 less card in my deck. So I've got 51 total cards in my deck now. I also burnt 1 of the kings. So I don't have 4 kings anymore. Now I have 3 kings. Multiply top to top, bottom to bottom. And I get 12 out of 2,652, which simplifies to 1 out of 221. You try example number 8, pause the video, and then we'll go over it in just a moment. Okay, the bell's going to go off here in just a second. Ignore it. There it was. So, example 8. A box contains 5 pennies, 2 nickels, 3 dimes. Okay, let's get the total number of coins in my box. 5 plus 2 is 7, plus 3 is 10. Find the probability of choosing a dime, and then without replacing it, the probability of getting a nickel. Okay, well, I've got 3 dimes out of 10 total coins. So the probability of me getting a dime is 3 out of 10. I take that dime out and I drop it down the sewer drain. So now I have 1 less total coin. I've got 9 total coins in this box now. However, I didn't drop a nickel down the sewer drain. I dropped a dime. So I still have all of my nickels. I still got both nickels. Multiply top top, bottom bottom, and you get 6 over 90, which we actually saw earlier simplifies to 1/15. If you have any questions, please let me know by leaving it in the comments or by emailing me, visiting me in the hall, whatever you need. Otherwise, good luck on the practice.